So my name is Zach Casper. I'm a product manager on the Kubernetes team. Happy to talk with you this morning. With me today is Ruxanda Danetiu and Shoucong Chen. Ruxanda is a product manager on our StackDriver team, and Shoucong is a technical lead on Kubernetes monitoring. So hopefully we will go through, actually I'm going to go back real quick. Hopefully today we're going to talk to you, let's see, about hybrid observability. I'm going to cover a couple things. Okay, so one is I want to describe for you how we think about hybrid observability specifically. And then I want to spend about 5 minutes or so talking about Kubernetes internal monitoring, how we use the system metrics to actually run the system, and then how does that impact your application monitoring. We'll walk you through a couple of different scenarios on GKE On-Prem specifically. We really want to focus on how this works in the on-prem world, and so there's multiple different patterns there. And then we're going to hand it over to Ruxanda and Shoucong, and they're going to walk us through a demo. So how does that sound? It sounds okay? Okay, so I talked a little bit about who we are. I would love to know a little bit about yourselves. So maybe I can see some hands. How many people are running Kubernetes today? Okay, so there's most people in the room, great. How many people are running GKE? Okay, still most people in the room. How many people are using StackDriver with their GKE environment? Okay, about half, that's pretty good. And how about Prometheus and Grafana users? Okay, that's probably about 2/3 of you. Okay, good to know. I think we'll have something interesting for everybody here. All right, so let's kind of get started here. And this is how I think most Kubernetes deployments look like. If you're running in the cloud, you're typically using the logging and monitoring tools that come with that cloud platform. So for us, that's StackDriver. If you're running on premises, you're probably running Elasticsearch with Kibana, Prometheus, and Grafana. And so, two very different tools for two very different environments. What we want to envision is a world where you have a hybrid solution that is consistent across on-premises as well as in the cloud. So the way we think about hybrid is it's the same tooling. It looks the same. It behaves the same. It's in the same screen, particularly if I have workloads running in both different locations. And so Kubernetes actually gives us the ability to do this, right? The whole point of Kubernetes was so that we can abstract away the infrastructure. So we can have a consistent environment no matter where it's running, right? So we have this amazing opportunity with Kubernetes to do this. And so hopefully we'll present a couple different patterns to do that, but the way we think about it is we look at StackDriver as the core piece that can stitch together to give you on-premises view as well as a cloud-based view of your workloads. Okay, but before we kind of get too much into the specifics, I want to take a step back and talk a little bit about how Kubernetes internally works. So we have all these components that rely on system metrics, such as the horizontal pod autoscaler, the scheduler. Like we need to understand your resource utilization on your nodes for the scheduler to work. We need to know system metrics for the kubectl top, so you can see all the resource usage across the cluster. But Kubernetes doesn't give us a sophisticated logging and monitoring system out of the box. But it does have this system level components. And so this is implemented with the metrics API and the metrics server. And so these two components work. The metrics server is actually going and scraping the system level metrics from each individual node and then publishing that up. So let's take a look at the nodes themselves. Okay, so on the nodes, obviously we have the kubectl, and then we have cAdvisor. How many people are familiar with cAdvisor? Okay, like a decent, like maybe a handful, maybe 10 or so, that's good. So cAdvisor is a resource usage collector for containers. It goes in, it auto-discovers all your containers, and collects CPU, memory, network, storage, et cetera. So the cAdvisor and the kubectl, they work together. These two components gather all the metrics from the nodes and publish those through the summary API. But going back to our bigger picture, this is what we call, with those, that cAdvisor and the kubectl, this is what we call this core metrics pipeline. This is a core concept inside of Kubernetes itself. But this is just for Kubernetes, right? This has nothing to do with your application workloads. This is all just the internal workings. So for my applications, I actually need a third-party monitoring solution. And so this is where we get to, now we need to talk about, okay, well, for GKE On-Prem, what do we use for that third-party monitoring solution? Okay, so let's take a look at that. What we want to do with GKE On-Prem is get you the flexibility that you want, right? We want you to use the right tool for whatever your purposes are. So let's see a couple different scenarios. So maybe you have GKE On-Prem and it's running your front end. And the back end is somewhere off the cluster. And you want to have end-to-end visibility for that. So maybe you want to use an existing Splunk environment. Or maybe you want the ease of a fully integrated cloud-based monitoring system. StackDriver may be a great option for you. Maybe you're interested in running workloads in GCP as well as on premises, right? And then you need that view across both different environments. So we want to get you the flexibility to use whatever tool you're used to. So a couple things. So Kubernetes out of the box, GKE On-Prem out of the box, rather. It comes pre-configured with StackDriver logging and monitoring. We're also shipping a Prometheus and Grafana instance. It's tailored specifically for GKE On-Prem. And I'll talk to you a little bit about what we've done. And then we're working with our partners, Splunk and Elastic, to make sure that all these systems work well together. All right, so let's dive into StackDriver just a little bit, and then I'll cover the Prometheus and Grafana at the end. So we're using 3 different APIs here, 3 different StackDriver APIs. First one's monitoring. So running on the cluster, we have a Prometheus collector. We have a pod, it's called the StackDriver Prometheus Kubernetes pod. And inside of that, we have Prometheus running that's configured specifically for collecting these StackDriver metrics. Next to it is a pod. We call it the StackDriver collector. So it's extracting the Prometheus metrics and shipping them over to the StackDriver monitoring API. We've done a couple of things here on the Prometheus instance to make sure it works well in GKE On-Prem. So we're doing things like we've expanded the duration of the buffer because we want to make sure that, like in a network outage, that the metrics are whole inside of StackDriver. So we've expanded the buffer there. A couple other things like that. Now this Prometheus instance, this isn't something you need to configure or worry about. This is really just an implementation detail. Okay, so next we have the logging. Logging is pretty straightforward. So we have a logging agent running on each of the nodes. Those are aggregated up into a logging collector. It just so happens that we're using FluentBit and FluentD. FluentBit for the logging agent and then FluentD for the collector. But again, this is just an implementation detail. And the last piece is the metadata agent. So metadata is pretty important to us because we want to give you a better experience rather than just straight logs and metrics. So with metadata, we can stitch together into a much better visibility across the cluster because we actually have some knowledge about what is actually running on your cluster. So with these 3 things, so we have logs, metrics, metadata. These 3 things will give you a much better experience. Okay, the last thing. So I want to cover Prometheus and Grafana. So not everybody wants to use necessarily StackDriver. So if pretty much everybody that raised their hand when I said like who's using Prometheus and Grafana. So we're shipping Prometheus and Grafana with GKE On-Prem. We've done a couple things to make sure it works well inside the environment. The first thing we wanted to do is we wanted to give you a multi-cluster view. Because with GKE On-Prem, you're going to have multiple clusters. Out of the box, you have an admin cluster and a user cluster. So with what we've done is configured Prometheus to have a multi-cluster view. And you can choose this kind of the scope that you want to look at. So if you want to see the multiple cluster view, you can use the Grafana instance that's running on the admin cluster. If you want to see just the user cluster, so say, for example, you have an application-specific cluster, and you want to give that out to an application team, they can use that Grafana instance. And then lastly, for those that really enjoy using Grafana, you can actually build dashboards that look at both the Prometheus data for GKE On-Prem, as well as data from your GKE clusters. StackDriver is a native data source for Grafana. And so you can have a dashboard looking at both different clusters. All right, so that kind of wraps it up. That gives you just a general overview of where we're at with GKE On-Prem. So a couple of different options just to review. Cloud-based, out of the box with StackDriver, and then certainly Prometheus and Grafana, as well as our partners. So with that, I'm going to welcome up Ruxanda and Shoucong. We'll walk through this demo.
Thank you so much, Zach. So next, we're actually going to go through the project. So we're going to actually look at how this works and integrated with StackDriver. So for the purpose of this, we actually build a demo project. This is the pet clinic. Adorable pictures always work at demos. The concept behind this is that you have a series of owners. So let's see who we have in the owner list. And we're going to try to figure out if Shoucong is on the list here and see if we can add a pet for him. So this is so you can have an idea of how these services look like. And while Shoucong does that, let's talk a little bit about what's happening on the back end. So we're going to have two clusters here. One cluster is going to run on GKE and on the cloud, and one cluster is going to be GKE On-Prem. And in this scenario, we're going to have the API gateway with 3 microservices in each location, and we're going to push all of the data to Cloud Spanner on GKE. So we can actually monitor both the GKE cluster that's running on cloud and the GKE cluster on-prem within the exact same visualization. So once Shoucong has completed this, we're going to go and see how we can actually get access to this information. And throughout the demo today, I'm going to show you 3 kind of main pillars of the experience you get in StackDriver. The first one is going to talk about Kubernetes monitoring out of the box, and this is a beta product that we have launched. The second one, what we're going to talk about, is going to be around the custom experience that you can actually build, so you can do your own custom dashboards as well. And then we're going to talk about alerting. At the end, Shoucong is going to take over, and he's going to give us the idea of how you're actually doing a troubleshooting. So right now, we're going to add some load. We're going to generate some load to this app in order to be able to see some alerts firing and how we do the troubleshooting towards the end of the demo. So he's doing this right now in the GKE console. For the GKE cluster that's running on GCP. You can see the 2 clusters right there. And then he's going to do the exact same process for the GKE On-Prem cluster as well. Wonderful. So let's go to the StackDriver UI. As we're going to the navigation within StackDriver, we can select Kubernetes monitoring. This is the experience that I mentioned before. It is an out-of-the-box experience for all users of Kubernetes and GKE. Right now, as we're selecting this is a beta product for StackDriver. Everything that you see on this page, as long as you're using GKE, exactly as Zach mentioned, all of these do not require a setup. Everything gets collected and gets reported for you. So we have those 2 clusters. One is on cloud and one is on-prem. And I want to give you a tour about the capabilities that you're getting on this page. So at the top of the page, we have the alert timeline. What we think is extremely core to the experience is to know when things get alerting. The troubleshooting workflow is fundamental. And here we want to actually showcase all of the alerts that you have within your Kubernetes environments that span both cloud and on-prem. So if you hover any of these cards, it's almost like a heat map. The more alerts you have, the darker the shade of red. And you get information about the alerts that have fired. Underneath this, we have these 3 tabs: infrastructure, workloads, and services. And we spend a lot of time talking to customers and getting to understand what are the different flows, personas, and use cases. And we've realized that in some cases, operators and developers might have different interest or entry points. So we build these 3 different tabs to satisfy somebody that's really interested in focusing on nodes and clusters and an infrastructure approach. But we also want to cater to developers that are more interested in deployments and services as well. So this gives a quick entry point to all of those experiences. We're starting with the infrastructure tab, and the 2 clusters are, as you can see here, we're going to open the GKE cluster running on cloud. And as you can, the table itself has almost like a hierarchy built into it. And while we know that Kubernetes and GKE does not have a hierarchy per se, but the metadata allows us to read all of these labels and actually build an intuitive way of reporting this information. So you can see your cluster, the nodes in it, the pods within that node, all the way to the container. And this level of drill down can be really helpful as you're trying to do troubleshooting, or as you're trying to find particular things, so you have the groupings to help you to navigate this really easily. At the same time, the table itself gives you at-a-glance information around the resource, the number of pods that are ready, the number of incidents, the CPU utilization, and memory. On the workloads page, we have a hierarchy that spans clusters, namespaces, deployments, pods, and containers. So you see that there are different ways where things can get clustered, and the hierarchy is really important as a way of getting to the drill down that's more significant to the workflow that you're interested in. And we have, let's pick for the API gateway for deployment. Let's click on one of those and actually look at some of the details of a pod. So for every single entry within this table, you get a details panel that gives you information, gives out-of-the-box metrics that are already created. You get these charts pre-populated for you, so it requires no setup. We have an integration with logging as well, so you're going to get a high-level histogram of the logs for this particular pod, and you're going to get a selection of logs filtered by severity for this pod as well. And of course, that's never enough, so you're going to be able to very quickly click on the entire logging experience. You're going to remain the context is going to stay the same. So here we are in the full logging experience in the GCP console, but we are only looking at that particular cluster, or that particular pod that we are evaluating, and that particular time span. So you can go and end up doing your troubleshooting there and do more filtering. And then we have details information as well. So every single, as we're going through all of this information, the details are really important, and you're able to go and get logs and metrics for every single entry within those tables. And of course, we have a deep integration with the Kubernetes and GKE teams, so you can go in and actually get a lot more detailed information from the GKE page in context. So when we go back to StackDriver, we can actually see the 3rd column is services. This gives you an ability to actually go through the entire hierarchy with services as well, and gives you information within kind of the same span of cluster, namespace, pod, and a service pod and containers. So let's go back to infrastructure for a second. The table itself has an embedded hierarchy, and it's interesting to navigate. But one of the things that is sometimes problematic when you have hundreds of these entities is really hard to understand patterns and being able to come up with insights of the way that maybe there is a trend out there that you're not able to see in a table format. So we built this bubble visualization just mostly because we really like bubble visualizations. No, but the idea is that it's going to empower you to use metrics. So we have a CPU usage on the x-axis and on the y-axis memory usage. Each bubble represents a node. The size of the bubble represents the number of pods in that node, so how big the node is. And then the color represents the health. So if it's a light gray, it means that it's healthy, and red means that it's an incident. And as you can see, there are all of these different clusters that are forming. There are all of these patterns of information. This is an exploratory tool that we're launching in beta as well. And we're trying to make this as a way of using the data that you have, the information that you have, and come up with interesting insights about trends that are happening across these. It's important to mention that right now we're looking at nodes that span both cloud and on-prem. So it's a fascinating way of understanding this behavior, where at the end of the day, what we want to get to a position in, especially with Anthos, is that you shouldn't care if something is on-prem or on GCP, and you need to have a single tool that manages all of these things for you, so your monitoring solution is in one space. So far, we talked about the out-of-the-box experience for Kubernetes and GKE within StackDriver. And while we understand that every single out-of-the-box experience out there is amazing up to 80% of the time, and then you're going to have some use cases where you're going to need to build something custom. So StackDriver allows you to get access to all of this information and build your own custom experience as well. So what we developed is this tool called Metric Explorer that gives you the ability to actually query all of the metrics that are coming in, all of your system-level metrics. And these metrics come in either from GCP or from on-prem. You find them within the exact same space. You can apply, as you can see here, there is a lot of information. We have a lot of lines on that chart and might not be readable. So maybe we want to apply filtering. So you can benefit from using advanced filtering. At the same time, we can group things by. We can add a lot of functionality and aggregate these information as well. And one of the things that we build is that sometimes we try to do a good filtering, we do a good job of bringing in a lot of data, but it's too much data to make it meaningful. So we've introduced modes and options for you to do an outlier mode, so you can pick to always show the top 5 outliers within your space, or top 10 or top 15, the number that you care, and make these charts really meaningful for you when you go in to know where the problems are, so you can investigate a lot faster. And as you can see here, there's a lot of trial and error. So we can spend quite a few minutes until we figure out what are the right metrics, what are the right filters, until you build your great chart. And you don't want to do that every single time you log into StackDriver. So we have the ability for you to be able to save these charts and save them in a new dashboard, add them to an existing dashboard, and these charts can be easily shared through your URL with all of your colleagues, so you have share the same context. So let's look at a custom dashboard next. So we can actually see this capability live. And this is a hybrid dashboard, so every single chart that you see on this graph displays data that is collected from both cloud and on-prem GKE. So a lot of this information is being brought to you in one single dashboard. You don't have to create multiple dashboards. You don't have to go to multiple consoles, have different experiences. Everything can come in one place. You can easily add more charts and make this customizable. And then you can easily play and delete things, so you can make this space really meaningful to your team. And we talked about the custom experience. Next, I want us to focus a little bit around alerting. We know at the end of the day, monitoring proactively it's time-consuming. It's something that you won't be able to just spend all of your day looking in front of a screen and waiting for something to go wrong. So we need to be really smart about our alerts. So we created an integrated alerting experience. So let's try to start the process of creating an alert. As you can see, the interface that you have access to right now is the same interface that we showed earlier, is the Metric Explorer interface. You have the ability, once you kind of get to know the system and start playing with Metric Explorer, that is the one-stop shop for creating your dashboards, creating your alerts. You're using the same workflow. We want to make sure that you don't have to have a ramp up of learning curve for each and every experience. So you have the exact same metric capability, filters, all of these things are brought in within the same workflow. So of course, you can edit these, you can add notifications, you can add critical documentation. These are really important. We really encourage all of our customers to use documentation heavily in their alerts and link to dashboards and provide links to books as well. So let's look at some of the incidents that we just created. So these will be displayed, so you can actually have a list of all of your incidents, and these can span alerting policies, and these can span both the environments that you have on cloud and on-prem. And now that we've covered, kind of just to bring everything together, we talked at the beginning about the out-of-the-box experience. We're hoping that that experience gives you an option to have visibility without any setup and be able to sustain probably the large majority of the use cases. Then we talked about the custom option. If you want to build your custom dashboards that are hybrid, that span both clouds, you have that option as well. And how to build really, really smart alerting that can help you navigate how not to get woken up at 3 o'clock in the morning. But because we created these alerts and we added some load to the app at the beginning of the demo, I think Shoucong just got paged, and he's going to show us what happens once you get an alert and how we troubleshoot this. So Shoucong?
OK. Thanks, Ruxanda. So this is Shoucong. I'm going to give you a demo about a very typical classical troubleshooting scenario in our daily work. So as a SWE, so we usually encounter a very common scenario is that when your application becomes more and more used by customer, you're receiving more and more traffic. And in the meantime, some of your server become slow or unresponsive. And usually it's like the moment that some on-call engineer will jump in and then figure out what's happening. And then we want to understand, is it due to a bad machine, due to a bad deployment, or due to something misconfigured? And it's become more and more complicated, especially when you have distributed setup, like a hybrid, also like a hybrid setup. You have GKE on cloud, you have Kubernetes, like on-prem or GKE On-Prem, and you also distribute it across many different areas. That is the scenario we try to demo here. OK, so as you may recall from maybe 10 minutes ago when Ruxanda started her demo, we generate some traffic to both of my GKE cluster and GKE On-Prem cluster. So while she's demoing, as an on-call engineer of this pet clinic website, I have been paged. So this is the alert I've received. So StackDriver sent me an alert talking about something HTTP server request count for 500 is too high. And based on the documentation, I know this is it means too many 500 has been returned for my services. This is a little bit concerning to me because returning 500 means my customer may be experiencing this outage now. So let's take a look at what incident detail page StackDriver tells me. So as you can see here, we are receiving around 12 requests per second of 500 for the service API gateway. This is a little bit concerning to me because API gateway is the interface of my application. So as a SWE, I go to the predefined custom dashboard, which has almost all of the important metrics I'm curious about my hybrid setup. So as you can see on the top two charts, so the first chart on the top left corner, This is the hybrid, the request counts go to both cluster in my hybrid setup. As you can see, I receive around 150 requests go to my GKE On-Prem cluster, and then around 200 requests go to my GKE cluster. This is working as intended because this is how my load balancer configures. All right, so let's take a look at the top right chart. So this is the error rates. So from this chart, it gives me very strong signal that something is wrong in my GKE On-Prem cluster. Because you can see here, all of the 500 are coming from my GKE On-Prem cluster. So as a developer, my first interaction is I try to dive into this cluster, GKE On-Prem cluster, to debug what the issue will be. But as like the Google SIE best practice tell me, the first thing I need to do at this moment is to mitigate the issue. So one of the very classical ways, we just drain this GKE On-Prem cluster and fail over the traffic to GKE cluster. Before we do that, I have one more thing I want to confirm for additional safety. So let's go to Kubernetes monitoring view. The thing I want to confirm is if I fail over, that means my GKE cluster will receive the double size of the traffic. I want to make sure my GKE cluster can sustain the load. So that's why I come to this infrastructure view. As I can see here, so CPU and memory usage for both clusters are around like 20%. And if I expand the GKE cluster, I see they have 6 nodes. And each of the nodes is running around 20% CPU utilization and around 20 to 30% of memory utilization. So it is like it still have plenty of space, so I can fail over. I think that's a safe move at this moment. OK, so let's go to this GKE On-Prem cluster. I just drain the traffic into this cluster. And then I go to this Kubernetes Cloud SSH, and then I just double the size. This is to simulate the failover. So in real world, we will have like a more advanced load balancer config we will do. But in this demo, we just simulate it this way. OK. So as we go back into this dashboard, I mean, usually the load balancer will like take around 1 or 2 minutes for the traffic to migrate. So eventually, we will see the on-prem cluster traffic goes down, and the GKE cluster traffic goes up. But we will not wait the time here to wait for that. We will go back after I finish my demo and then to verify this is the behavior. OK, so that I believe the current outage is reasonably mitigated. As a developer, I want to debug the root cause of the issue. So that's the moment I go to my service tab, because that's the thing that is alerting. I see this incident column has given me very good hints, like something is wrong in on-prem cluster. This is another way we can narrow down the issue. And we go to like this incident column, keep telling me where I should focus my attention to. So this is the API gateway. I should take a look at this pod. So let's open this pod detail view. I see there's an open incident that's too many 500 has been returned from this container. Let's look at the metrics for this specific pod. As you can see, container restart, there's nothing restart, which seems great. Memory utilization is flat because this app is not memory heavy. Most of the data is storing in the cloud spanner. For CPU utilization, we see like from around 15 or 10 minutes ago, they have some CPU spike. That's expected because we generate a lot of traffic. Storage usage is also flat because we don't write anything. Network usage is high. This is also like caused by the traffic increase. OK, so if just looking at the metrics, seems everything is looking great. It means my Kubernetes infrastructure is running healthily. Then what could be the issue here? At this moment, this is the moment where log can help us a lot. So if you go to log tab, we see the log rates here. This gives me a very obvious signal something is wrong because my application is writing a lot of error logs. As you can see, this is around like 40% or 1/3 of logs are written as error log. This is very suspicious because normally we don't write so many error logs. And we go to the snippet, we see, OK, there's indeed some error logs here. Let's go to logs viewer to see the more details. So this is already an expanded arrow. So we can see for the detail here, we can see this is a Java runtime exception have been thrown. And it gives me the full stack trace. So I can go to where the thing that's happening in a very concrete detail. So let's see what this means. Let's just fetch, OK. Fetch this line. Let's go to the code. So this is where my code base is. So I just do a grab of above error message. I can see this is something that is written in the API gateway controller in Java, and then line 54. Let's just open that file. Unable to fetch. OK. So at this moment, it's quite clear to me like this error message or this 500 error has been thrown because somebody write this line of very suspicious functionality. It's basically just like it toss a coin before returning a successful request. So there's a 50% chance that you will not be able to get your traffic. Get a correct result. So till this moment, so we have already identified the root cause. The root cause is somebody introduce a bug into the code and then deploy it into my GKE On-Prem cluster. So the next step for me are very clear. I will just fix the bug in the code, redeploy into the GKE On-Prem cluster, and then unstrain the GKE On-Prem cluster. Then we can make our application back to normal. So this is the end of the demo.